Hello everyone, welcome to Developers Checkpoint, and in today's video we are going to explore the architecture of Cassandra. Cassandra is a database which is used for read and write operations at the planet scale. In this video we are going to explore the very high level architecture of how Cassandra works and how does it perform read and write operations. In this video we are going to learn about gossip and failure detection, snitches, rings and tokens, coordinator node, and how read and write operations are done in Cassandra. So without any further ado, let's dive into the video. So we will start with failure and gossip detection. So gossip detection protocols are used by distributed system to identify the health of the various nodes. As we know that Cassandra has a number of nodes which are used for read and write operations. There is a gossiper node which tries to connect with all the nodes and keep a track of the health of each and every node. So how does the gossiper works? So gossip detection protocol works something like this. So there is a node which stores the data and there will be a gossiper node. Okay. So gossiper node will keep on pinging the node in regular intervals with a gossip digest sync message. And if this node is healthy, it will revert to the gossiper with a gossip digest acknowledgement message. So this means this node is healthy and is able to revert to the gossiper. And if the gossiper has received this gossip digest acknowledgement message, it will revert to the node with a gossip digest acknowledgement 2, which means that the gossiper has recorded this node as a healthy node. So this is a scenario that how a healthy node responds to a gossiper. Okay, now let's see a scenario where the node is unhealthy. So the gossiper will ping the node with a gossip digest synchronous message, and in this scenario the node will not be able to revert with a gossip digest acknowledgement message. So if the gossiper does not receive this message, the gossiper will assume that this node is going to be unhealthy. So there comes a very important algorithm here which is known as free-accurate failure detection algorithm. So this algorithm detects that the gossiper and the node must be separate entity. So the thing that has to be monitored will be different from the thing that is monitoring this. And the other thing is the response of the gossiper will not be a boolean. It will be a number which tells the suspicion level of the gossiper. Okay, so if this node is not able to respond to the gossiper will suspect that this node is about unhealthy, but will not mark it unhealthy immediately because there can be lag at the network layer as well. So what will the gossiper do? The gossiper will increase the suspicion level of the node that this node might be unhealthy. But if this node continues to fail to respond to the gossip messages, this gossiper will keep on increasing the suspicion level and will ultimately mark this node as an unhealthy node. Now let's move to the snitches. So Cassandra is a distributed system which is having a lot of moving parts or lot of nodes in it. So snitches help us to identify that which of the nodes provide the minimum latency for the read and write operations. Okay. So there are many type of snitches, but we are generally focused on two type of snitches, which is simple snitch. Simple snitch identifies the node in a single data center. For example, in a single data center, which of the racks have providing the minimum latency for the read and write operations. The another type of snitch is the dynamic snitching. So as we have earlier discussed, the gossiper keep on tracking the health of the various nodes. It keeps on tracks the latency of the various nodes. The dynamic snitch uses that data to identify that which of the nodes will provide the minimum latency for read and write operation. So the gossip protocol provides the failure detection as well as it contributes to the dynamic snitching, and that dynamic snitching is used for making the database faster by identifying the nodes which will provide the data with the minimum latency. Okay, let's move ahead to the rings and tokens. So Cassandra has an architecture where it distributes keys to the various nodes. So what it basically does, it makes the hash of the primary key, and depending upon the hash of the primary key, it distributes those primary keys to the various nodes. The partitioner uses consistent hashing to identify the nodes on which the read and write operations are to be done. So we are going to provide this node with the responsibilities of keys from 1 to 100 and this node from 101 to 200. Okay, so this interval or this range for which the node is responsible for read and write operation is known as the token range of the node. So this node can participate in all the read and write operations for the particular key. For if the key is less than 100, this node will be participated, and if the key lies in this range, this node is going to participate in read and write operations. Moving ahead, let's move to the coordinator node. Coordinator node plays a very important role in Cassandra. So suppose you are going to make a read and write operation to a database. So you will choose any node in the Cassandra database. So suppose this is the coordinator node. Okay. Now this coordinator node is going to take the hash of the primary key. After taking the hash of the primary key, let's say the value of the hash is 15. So let's assume that this node is having the responsibility of handling the keys from 1 to 100. This coordinator node will request this node to perform the write operation, and apart from that it will ask few other nodes to keep a track of that data, so that we can have a distributed network or we can have multiple nodes for the write operations. So in case this node is going to fail, we does not lose data. Okay, so that's about the coordinator. Now let's move ahead to the read and write operations basics in the Cassandra. So what is going to happen when we are going to perform a read and write operation to Cassandra? So let's start with a write operation. So suppose we are going to write a value of key a equal to 10 in Cassandra database. So all the request will go to the coordinator node. Coordinator node is going to take the hash of the key, and let's suppose the hash value is 15. So the coordinator node is going to send a request to the node that is dealing with that partition range or that token range, and this node and ask this node to save the value of a is equal to 15. Apart from that, it will also ask few other nodes to keep a track of this record, and what node it has to reach out, that becomes the part of the snitching algorithm, the nodes which provide the minimum latency for the read and write operations. Okay, so in this way we are going to perform a write operation on a Cassandra database. Now let's have a look how we perform a read operation. Now let's look at the scenario where we are going to read about the value of key A. So the request will go to the coordinator node. Coordinator node will do the hash of the key and will come up with a hash, and from the hash value it will identify which node is going to contain that information. So suppose this node is containing that information, so the coordinator node is going to make a request to this node. Okay, so this node is going to make a request to this node for the particular value. Apart from that, it is also going to make a request to other nodes for the value of this key. Now let's assume that two of these nodes responded with value of a is equal to 10, and this node is responding with a value of a is equal to 5. So in this case, the coordinator node will revert the client with value of a equal to 10 and is going to ask this node to update its value from a is equal to 5 to a is equal to 10. Such type of mechanism is known as the read repair, where the coordinator node is trying to reach out to various nodes, read their values and identifies that which of the node are having an outdated value and explicitly ask them to update their values. Now assume a scenario that we are going to write a value on a particular node. So the request has gone to this node and this node and this node, and assume a scenario that somehow this node is not available at that moment and the write operation on this node is dropped. So what the coordinator node will do, coordinator node will keep a track of this record. So it will keep that the value of a is equal to 10 has to be updated on this node, and this mechanism is known as the hinted handoff. Cassandra database also provides the functionality of tunable consistency, which means the number of nodes we want to write and the number of nodes we want to read from. That can be tuned in case of Cassandra to make the trade-off between the consistency and availability. For now, let's deep dive into what happens then this particular node is asked to write a particular value. For example, a is equal to 10. So the Cassandra database is based on the LSM tree based architecture. You can find the link of the video where LSM trees are defined on the top of the video. So if we conclude on the top level, we can say that in Cassandra there is a coordinator node which has the responsibility for performing all the read and write operations. The coordinator node uses snitches for identifying the nodes with the minimum latency. The coordinator node is going to create a hash and will identify the node that is responsible for that token range. It will make the request to the node handling that token range, and that node is going to write all the data in a LSM tree based architecture. So guys, that's about the video. Please like the video if you like and subscribe to the channel. Thank you.